Welcome to The Explainer, where we break down big ideas. Today, we're asking a question that honestly feels more urgent every single day. Can a machine actually think? Or is it just an incredibly sophisticated parrot? So to really get to the bottom of this, we're going to dive into one of the most famous and frankly most brilliant thought experiments in the history of AI. It's a simple story that challenges the very idea of what it means to understand anything at all. I mean, think about it. You probably talk to an AI every single day, right? The large language models we use can write beautiful poetry, they can find bugs in our code, they can even hold conversations that feel, well, they feel real. They act like they get us. But is there actually a mind in there? Is anyone home? But this isn't some newfangled question that just popped up with modern AI. This is a puzzle that philosophers and computer scientists have been wrestling with for decades. And it was all brought into sharp focus way back in 1980 by a philosopher named John Searle. Okay, so let's get into it. Searle was really skeptical about the huge claims being made about artificial intelligence, especially this idea he called strong AI. So he came up with this thought experiment to put those claims to the test. Now, it is super important we get this distinction right. We are not talking about weak AI, where computers are just really, really useful tools for us. Nope. Strong AI is a whole different ballgame. It's the radical claim that with the right software, a computer isn't just pretending to have a mind, it can literally have a mind, with real thoughts and real understanding, just like you and me. And this is where the experiment gets so cool because he puts you right in the middle of it. Imagine this. You're locked in a room, all by yourself. And here's the key. You don't speak or read a single word of Chinese. To you, the characters are just, they're just pretty squiggles on a page. And all you've got in there with you is this massive rule book, written in English, right? And the rules are super simple. Like, if you see this collection of squiggles come through the slot, then find the page that matches and write down that collection of squiggles on a new piece of paper. So that's what you do. You get symbols, you look them up, you write down new ones, and you pass them back out. You're just a symbol shuffling machine. Okay, but here's the kicker. This rule book, it's perfect. It's so good that from the outside, your answers are flawless. In fact, they're indistinguishable from the answers a native Chinese speaker would give. The people outside are having a full-blown intelligent conversation with the room, and they're convinced they're talking to someone who understands them perfectly. So, here's the million-dollar question. Do you, the person inside the room, understand a single word of Chinese? And the answer is, of course not. Not a thing. You have no idea if you're talking about the meaning of life or ordering takeout. You're just following the rules, manipulating symbols that are totally meaningless to you. And that right there is Searle's big gotcha moment. You, a conscious human being, have basically become a computer. You take input, you process it based on a program, that's the rulebook, and you produce output. So if you don't understand Chinese while doing all this, how on earth could a machine, just a pile of silicon and wires doing the exact same thing, possibly understand? Well, as you can probably guess, this simple little story completely blew up the worlds of AI and philosophy. People came out of the woodwork to push back, trying to figure out where the mind or the understanding could be hiding in this scenario. The first and maybe the most famous counterattack is called the systems reply. And people who support this idea would say, hold on, Searle, you're looking for the mind in the wrong place. Of course, the person in the room doesn't get it. They're just a cog in the machine, like a single neuron in a brain. It's the entire system, the person, the books, the room, all of it working together. That's what understands Chinese. All right, next up, we've got the robot reply. This argument says the room's real problem is that it's just stuck. It's disembodied. But what if you put that whole system inside a robot? Give it cameras for eyes, microphones for ears, arms to interact with the world? Now, the symbols aren't just abstract squiggles anymore. They're connected or grounded in a real-world experience. And maybe, just maybe, that's where genuine understanding comes from. And then there's the brain simulator reply, which is kind of the go big or go home argument. It says, forget this simple rulebook. What if the program wasn't just some rules, but a perfect neuron-for-neuron simulation of a real, live Chinese speaker's brain? The idea here is that if you perfectly copy the cause, the brain's physical processes, you've got to get the effect, which is real understanding. But here's the thing. For Searle, all of these replies, as clever as they are, completely miss the point. Because for him, this entire debate just boils down to one crucial difference.
And that is the massive difference between syntax and semantics. Syntax, that's just the rules, the grammar. It's pushing symbols around based on their shape. That's all the person in the room is doing. But semantics, that's the real deal. That's meaning. That's the actual understanding of what the conversation is about.
And what's so powerful about Searle's argument is how he uses this one idea to knock down every single reply. To the system's reply, he says, fine, let the person memorize the entire rulebook and do it all in their head. Now the system is inside them, and they still don't understand. To the robot reply, the inputs from the cameras are just more symbols. And for the brain simulator, a simulation of a rainstorm won't make you wet, and a simulation of a brain won't make it think. It all comes back to his central claim, his unbreakable rule. You can't get meaning just from shuffling symbols. No matter how fancy the rules are, syntax alone is never going to be enough to create real semantics. So where does that leave us? Today, with AI that's way more advanced than anything Searle could have imagined. If he's right, then it doesn't matter how smart our chatbots seem. They understand nothing. So where could understanding even come from? Well, Searle's own answer was something he called biological naturalism. Basically, he believed that consciousness, real understanding, isn't a software problem, it's a hardware problem. It's a biological phenomenon that our specific, squishy, carbon-based brains just do. He thought there's something special about the actual wetware that you can't just replicate with code. But you see the problem here, right? This leads us straight into a classic philosophical rabbit hole, the other mind's problem. I mean, how do you really know that I'm conscious? You can't crawl inside my head. You just assume I am because I act like it. We give each other the benefit of the doubt. And that, right there, is the huge, mind-bending question the Chinese room leaves on our doorstep. If a machine's behavior becomes completely, totally indistinguishable from a conscious being, if it walks like a duck and talks like a duck, what right do we have to say it doesn't actually understand? At that point, is insisting it needs a special biological spark just our own form of prejudice? That's the puzzle we're all trying to figure out right now.